Okay, dear friends, welcome back to our next lecture in the series of blockchain development. So here I'll be giving you the complete code and the how it works, the code breakdown, and I'll explain each part of code of how it is working, and the web portal, the front end and the back end completely. So let's start with the code and let us have a first glance of code of how it is working, and then we'll move on for the rest. So this is our main code main.py. Now in a web portal and a Flask we have app.py or main.py that controls all the working of our all the working and the logics of our functions. Here we have the Python applications, everything written in this main.py, and we link all the login and sign up and profile pages for document upload and verification with the help of this main.py. So here we'll first import Flask, then Flask logging is a setup for login required and current user determination. Fids is another which is used for PDF to text conversion and all to extract pages and the information from PDF file. PDF 417 is used to generate the barcode. Web3 is for the uh, Web3 is for the blockchain related setup, and PDF 417 is for decoding the generated barcode which has been encoded by PDF 417. Then there is the network information in BCN file, and we have used this encoding for our encryption purposes. So I'll go through this first. There is a function of route in Flask. Everything is written like you have main.py, so you have main.route here. You see this, and route will be used above all the functions, and this slash indicates index. So whenever I go to the home page, it will be routed to this particular definitions, and it will return or render the template of index.html. This is the HTML file. This is the profile file. So again, if I am logged into to the portal and then it has to display something, so that is again routed to the profile.html with current user who is being logged in. So this is the variable which is passed to this profile HTML. We'll see how this profile HTML takes the name as the variable, and here at the rate login required is again to visit profile user must be logged in. Then third is upload, so user can upload the PDF document, but here also user needs to be logged in, and upload.html will be shown here. Then this is something about network interaction. This we'll discuss in brief of what it is and how it works. So Web3 function, how it interacts with the network, and yeah, just wait. How it interacts with the network, what are the gas charges, what is the chain ID, and what is the data of the contract. Then what's the contract address, we'll see this. Then we have to first establish the connection, determine the decimal value, get current user account balance, and then all those things we are doing using network interaction. Network interaction means we'll interact with network and try to write some values onto the network in simple terms. Here we see that we have sent a raw transaction, or in a sense that we have written something onto the network. And please remember, writing something onto the network costs gas charges in terms of blockchain, and gas charge is nothing but the amount you need to pay for writing something onto the network. And this amount is less than $1. It's about 10 or 15 rupees depending upon congestion and how fast you want to execute your transaction. So this is all this is like another thing which we'll discuss in our next lecture about how blockchain works. But right now, just understand this: we need this particular interaction to sign a document and verify the document also. So then this so this is done, this network interact. Now this particular thing is don't come under route, so any public user cannot access this particular definition. So these has the internal access, like the internal some files are there. Yeah, which is calling this particular, there is some internal function which is calling this network interact, and similarly it is calling this decrypt info. Now in our system, in our setup we have an option of uploading PDF file and user credentials. User credentials contains user ID and password. Now these user ID and password, just like any banking system, we do have here, because we are dealing with currencies and coins, so we do have a user ID and password, and that has to be in some encrypted format, and that encrypted format is provided to you by the administrator of the web portal or administrator of the contract or anything. So, or you can also generate it if the portal has this facility. Well, this can be done. So this is the format of decoding the encrypted user credentials. So here you will get three things: a public account key, like the public address, and the public address you'll get here, the public address, private key, the private key of the individual will get here, and the signatory name. So these three values are stored in user credentials. So they have to match. In order to sign this, in order to sign any PDF, these value has to match with what we are providing while signing. So that's thing. Now come on to the file save. This is again some this internal file, private file, and it cannot be accessed. So what it is doing here is we have uploaded some PDF file, and that PDF file will be saved somewhere. So we are just uploading the PDF file and saving it in some other norm format, after obviously attaching the barcode somewhere. Yeah, after attaching the barcode in at this particular location. So this is the location, page number dot rec dot height. So we'll have multiple pages, so we'll do it only on the single page, and page number file handle is 0. So 0th page is stored in page number, and we'll get its its height and xmin, ymin, xmax, ymax, and then we'll at that particular location we'll insert an image, and this image is the QR code or the barcode which we have generated, and then we'll save it as a signed dash something. So this is again the internal function. Here this confirm number of images, this number of images, something like do you have any barcode in the signed document. So this particular function is called when the user tries to verify the PDF, signed PDF document. So the user has the option of first uploading it through the index.html, and once the user uploads it, we will be able to get that particular file, save that particular file, and then we'll be able to save that particular file, open that particular file, and then get the image which is there in the and get the image, extract image which is there in the PDF file. So there may be like right now what we are doing is, while signing we are attaching images to the PDF file. There may be other images attached also to the PDF file. We'll get all those images, and then we'll try to decode it. Once the image which has which works on this function and returns some particular value will display onto the web screen or portal. So if there are other images also, and since the other image will not have any barcode kind of, so this particular coder will not return anything, and our decoder will be 0 or null. In that case nothing will be returned. And so for this confirm number of images for the verification purpose and all. And here we also have, while after signing we have an option of downloading the signed document is provided by this particular route functions. Then this is for the uploading. So I've already told about the user credentials, where we need to upload user credential and PDF file. So this particular uploader calls everything, like it has the option of wherein we upload the PDF file, save the PDF file, upload the credential file, save it, and also get the password. We match the password with the password which is already present in this JSON file. There is also password which a user has already entered while creating the credential file. So the password has to match. If it matches, Then like here we see that JSON file is f1 dot file name, it is open and it is loaded, and then somewhere we have called decrypt info. So we see that this particular file is loaded JSON data and it is passed through the decrypt info, which we have said earlier that it will be decrypting the three information: name, public account key, and the address. And this is done after verifying the password, which user also enters from here. And on the PDF front, we first upload the PDF, we open the PDF, we load the page, we get all the text and remove all the non-alphanumeric characters. And once the values are removed, we then encode everything and then create a SH256 hashed value, which is then submitted to the network. And network submitted means the network interact function, which I've already discussed earlier. This particular hash value is given to this network interact with these particular information. Like this is the value which has to be stored onto the network, and it has to be signed and executed by this person name using his public account address and the public key which he has provided. So this, after, if it is successful, we'll get something like something return transaction, like we get some receipt after doing any transaction. Just like here we get some kind of hash, transaction hash, tx hash in WA val, and then we'll sum it up. Like the name of the user is this, who is performing the action, then the transaction blockchain transaction hash is this, and the PDF hash or the hash value of the text document which we have obtained here will be just written in text and then encoded and rendered to form a barcode. Okay, because this encode function, encode text, you see we have called it from here. This PDF 417 calls the encode function. So we can see that this text is then converted to barcode and then it is saved in some JPG file format, and then yeah, this particular thing is saved in JPG file format, and then file save is called, which reads this, which is passed this particular file name. And we have already seen what the function file save does is, you see the file, it takes the barcode, it takes the file name, then open the file name and attach the email address, image name. Yeah, this is the image name. It opens the image name and then attach to the file. Okay, that is what it is doing. And then finally, if it is success, it will say that this particular signing is success, and it will display the name of current user, the file name, the name of current user, the transaction hash value, and the PDF hash value, and a download link, So this is how it works. Now the verification purpose, we have already. Yeah, this is so. Although it is in the last, but suppose if after I have signed and given it to the user, the college student goes to recruiter and recruiter needs to verify it. So in that particular verification purpose, we can use something very similar like this. Yeah, he can just verify this particular post by he will upload the file. The file will be saved onto the server, the file will be opened, the pages will be loaded, it will extract all the values here and message values here. It will again then interact. Just wait 1 minute. Is it called somewhere verification? Okay, just wait. So the verification was the earlier function which I have written, but it's not working here. So the same verification is done by this confirm number of images. So this verification is the other thing, which is just for the learning purpose, and this is not included in our task. Okay, this particular route is not called. Okay. Okay, friends, I've shown you how the complete code works. Now let us look at the working examples. And in the very initially, let me tell you that the Ropsten testnet on which I have developed this code is now deprecated, and since 5th of this October. So we may not be able to sign it right now because the Ropsten testnet is not writable, like it's only in the readable format. So but we'll be able to visualize of what has been done and how it is done. Okay, so let's start. Initially we'll move into the directory where we have this all code structure, and I'll show you the code structure. So this is the code structure here. Here we have main.py, we have credential file, we have auth.py, authentication, login and all, and then we have these templates of different HTML file format, and then we have the CSS and JS files and other things. So there is another thing also to tell, that this particular database is in MySQL. So you'll have to learn a bit about MySQL also. I'll show you a demonstration, but yeah, it's required for database maintenance and all. So I'll first, since just now I've checked it, I'll first close the earlier one, localhost, and then restart again. So I'll start my main.py like this. It might take some time. Yeah, see this. So my local server is now running at 127.0.0.1 colon 5000. Let us first copy this. I'll first copy this. Then I'll paste it in my local browser. There is something to see, I'll tell you later on. So this is my web page which has been designed. Okay, this page, there's a single page. You'll see service, portfolio, testimonial, price. What I'm worked upon is login and sign up, and the profile, which is not given here. So this is just like in future if you want to write your own code on this, so you have this functionality, price and portfolio, and it can be anything as per the text, can be anything as per your requirement. So I have not included anything here, but it's based on your requirement and your interest. What I'm interested is in verifying the signed text and signing a document. So let's start this. I'll first do a verification of already signed document, and then I'll show you other things. Okay, so let us first browse our directory PDF file and submit it. So I'll browse my PDF file first. This 1.1 I've created, it's a signed one, and 2.pdf is not the signed one, but 1-1.pdf is my signed document. So we'll see what it is. Let us first browse it, open, and I'll submit it. Now it is interacting with the network, and you see this is the transaction hash and this is the PDF hash. Now let us look what the document is first. So as you can see, this is 1.1 PDF, and this PDF has this particular information. This is the barcode, this is our signature, and the other page does not have it. So this barcode has this information, transaction hash and this PDF hash. So the PDF hash corresponds to text in first document. So now we'll go on to the Ropsten test network to see what this transaction hash has. So I'm looking at the Ropsten testnet, and I'll copy this transaction hash, because this is the value which is also stored in the barcode, and it is also stored in on my network. So I'll paste it here. Just wait. Yeah, I'll paste it here. And okay, I was telling you that the test has been discontinued and is in read-only mode by October 5th, 2022. So it's no problem. There are other testnets also. Will deploy and create a new contract there. But right now, since I've already done this for this particular work, so I'll keep this as it is. So you see, 9 days before I've created this, I've signed this document with this particular transaction hash. You see this transaction hash here, and you can see this. It has AFA6E. AFA6E. So this corresponds to the same transaction hash which has been decoded from our barcode, and it contains other information also, like this particular address of the signing user. This is the contract address. This is the same contract address which was given in the code earlier, and the main information is here, and it corresponds to this particular hash value 965E5, and you can see 965E597. So this is the hash value of that particular text in the document, PDF document. So that QR code has the same information as is shown in here, and it was signed 9 days ago. Now in any case, I will not be able to get the same transaction hash anytime, like it's not possible on blockchain. So this particular transaction hash will have this particular information embedded in, and it was assigned between these transaction, like these users, this user and this, my recipient and signing is same, but it can be different also, there is no issue. And there is one more thing, is it's done on this particular contract. So these information is never going to be changed in future, and the date and time, obviously, that it was signed on 29 September 2022, and you see it has about 33,000 block confirmation, and this means that it has been copied by 33,000 nodes throughout onto the network. So like you have n number of validators here, and you cannot, if you want to change this value somehow, so you'll have to change all 33,000 information, and it can be also like all those blocks which has been mined or generated since 29 September has to change, because the hash corresponding to this complete structure is somewhere embedded in the next block, like 130635450 has this many number of, yeah, it was generated 22 9 contract internal transactions. So there, so actually it has a set of information, this particular block, and the next block, see, the next block has this particular set of information, and then the other one has this particular set of information. Now in order to change the information on this particular block, you need to change information on all subsequent blocks and on all the nodes in the network. So that's practically impossible unless and until you master all the nodes. So that's something which make the blockchain unique. So this is how we have validated a signed document. Now let us look at the login and sign up. Okay, so you see localhost is not in the list of supported domain. There is something, the reCAPTCHA provided by Google. This I wanted to show you, and that's the reason I kept it 127.0.0.1. If I change it to localhost, this, so the reCAPTCHA, I am not a robot, will come, yeah, like this one. So this is again something like you need to include, otherwise there are scammers which will then do a DDoS or bombard your this login page, form page with the automated query. So you need to put this particular reCAPTCHA or CAPTCHA for safety of your web server and all. So we'll first create from the sign up page, we'll first create an ID, and then we'll see how to log in. So I'll create a random one, bh.po, something like this. Then the name, the second one is the name, it will be PO, and the third one is again a PO. Now I'm not a robot, I'll do this, and then I'll do a sign up. Let's do this sign up. Now it is already signed, and the information is already in the network, and AS dot, just wait 1 minute please. Now if I try to log in again from here on this particular email ID and password, I can see that whether I'm trying, see, it's saying that you need to verify your email first. So this feature is also included, and it needs to be, because it will verify your identity, and also like since it's the best practice to secure your server and all. So we'll first in actual case we'll have a email system wherein I'll throw a verification link to the email, and the user has to click on the verification link, just like it happens everywhere else. But here, since again May 2022, Google has disallowed users of this verification link from third-party app. I don't have an email server to do this particular task. Hence, I will be validating or verifying the email ID using MySQL structure, which I'm the admin. So whenever I in the next time I'll get that email server, I'll try to automate this login. So let us look at that email MySQL structure. So I am here in my CMD command prompt, and I'll do this one. And just log into the MySQL server. Now this is, as it is from the learning point of view, I've not changed the username, and it's just root with a random password. And once it is, then so now you can see that I'm here in my CMD, and I'll be logged in, and this is my random password. I'll use my database. DB is my random database, and then I'll see what is the status of the verification from my user table in the database. And as you can see that the email ID corresponding to the email ID, which is this, the verification status is 0. That means I'll not be able to log in here. So what do I do? What do I need to do is, first I need to update my database. So I'll be updating user. Set user is my database, set where status is equal to 1, where email equal to po@bh.po. So here it is now updated, and we can see that we have this one value. Corresponding to this, we have this one value. And the other thing, you must also know that this is the password which is created, which is hashed, and that entered into database. I cannot write password as it is. And also verification code that will be used later on when we will be able to connect with the username. PO is the name. So now, since my database is updated, we'll try to go back to the login page and see if we are able to log in or not. So let's go back. So I'll write po@bh.po, and the password is very much same, and then I'll do not a robot, and first I'll try to sign in. Now you see we have 3 different options here: upload PDF file, upload your key, and profile password. This PDF file is the same which we want to upload, and key is the other thing which will be the user credentials, and finally the profile password. Now if you want to look at again the profile one, so we'll see first the profile page here. So this is my profile page, and this profile page has a form with 3 entries, and the 3 entries are the PDF file, JSON file, and the password. And the password is then everything is required, and it is then sent back to the main.api, which this one action uploader, which invokes this router. Here the same thing, that we receive 3 different informations: the file name, the JSON file, and the password. And then we read the JSON file, we read the PDF file, we get the page content, we get the text content, we encode the text value, we get the hash value, we get decrypt the information in JSON file, then we interact with network, and then the information which we are able to receive is encoded and saved in the file, a new PDF file. That's how it's work. And then the method of success is shown, and method of success is simple: file name, signing authority, transaction hash, and dark hash. just let me remind you that this particular signing feature currently is disabled, and it's not more than a week that earlier I have developed this particular contract, and now that it is deprecated. So that's I've already shown you both. So when and similarly we'll browse and upload the key or the JSON credentials, and then we'll upload it here. The password is the same which has been used by the cred.json file. Once all the information is included, I will then submit it. And now I don't guess it will work, because I get this reason because the Infura is rejecting this connection or the writing information from the Ropsten, because the information in Ropsten is deprecated. But it's okay. In the blockchain session, I'll be showing you of what will be the output here. Okay, so then finally this is my profile page. I'll be able to, we can go to home also, there's no issue. We can have verify also, and we can commit also, but and we can log out also. So let us do one thing. I am here, I'll just log out here. Okay, now if I am able to submit, now if I am able to go to the profile page, it gives me this login. Please log in to access this page. This means that the session is broken once we do a logout. So this is very necessary, and it is the format which is followed everywhere else. That is what we are following also. Okay, so that's the complete set of information. Now we need to look at the login HTML and sign up HTML. We'll look at one by one. In the login.html, first we'll see the sign up. In the sign up.html, we have this Jinja notification, what is the message and all. We have this post form with sign up route or the action, and here we take 3 input parameters here, that is email, name and password, and that we can see in the sign up page, name and password. Then there is a Google reCAPTCHA, which is something interesting to see, and I'll show you how to get this Google CAPTCHA, which is both on the sign up and the login page. So here just you see that you have a data site key, something like this, and you import this Google API, reCAPTCHA API. So there are 2 information in the sign up.html, and the remaining information will be in this sign up route, that is here. So this is the sign up, which is in my auth.py file and not in main.py. So here we get the secret from the Google reCAPTCHA API, and this is the format which is provided by Google itself. Like if the reCAPTCHA is entry is successful, it will return the success. And here we get both the email ID request, the name request, the password request, and then we'll first sort all the email. First we'll query the database to find if there is an email which is already with that particular name or with that particular email ID. If it is so, it will flash out that email already exists, and it will redirect the user to enter another email. And then there is an option of this one, which I was already referring about, the verification code, and here you can see that there will be a verification code which will be the hashed password of email ID, which is entered by the user. So once it is done, so the user will have to verify it, although it's not working right now because of web server limitation, email server limitation, but it will work in the when we have access to it. So the new user will have a email ID, name and verification code, password. Okay, and verification status entered into database. So if the new user information is this, and if the captcha response is true, we get this request.form gcaptcha response as true, then we'll add the new user, we'll commit to the database and redirect the user to login. Or else we'll say that are you a bot, like if the captcha does not match. So this is how it works. So we'll see both the things one by one. Here I am entering some random email ID, and IO is my name, IO is my password, and then I'll say that I'm not a robot. I'll not take that particular captcha, and you see it is saying that I am a bot, similar to the thing which is flashed in, which is written in my code. Similarly, if I do again, and we can also check this on the database. And in the database, if we write something, there is nothing like io @io.io. So we can again try this with the captcha, and then we'll see what happens. So that's, now we can do io @io.io.io. I'm not a robot, and then I'll do a sign up, and now you see we are in the login page. So the captcha and the reCAPTCHA is necessary, and that is also included in this particular code. And on the MySQL front, we are able to see a new entry in our database. So this is how it's done. Then okay, this is also for the send email. Like here, the send email, once you get this particular verification code, you'll send that verification code to the email ID which is already received from the user, and the command for that is also shown, like the function for that is also shown here. You'll have this the sender ID, the password, and the recipient email ID, and this multi-part email, and it will join all different recipients, and this will be the link. So this is my IP and verification link, and they'll click on that particular link from the email ID. So this is SMTP Gmail server with 587 port, which now does not work. Like they have closed this particular third-party applications. So but here, in case you have any other web email application, you can have the same sender email and the password there, and then you can do the same thing, but you can also change this particular SMTP server protocol and its port, and then retype all these information. So we have seen this send email and sign up page, and this is a very simple logout feature which is provided. So once the user click on logout, so it will direct to this particular route, and then it will log out user and direct the user to main.index. There is one more last thing remaining, that is the login page. So login page also has this particular feature. If you see this, so you have seen both sign up and this send email, and the final one is a logout. When the user click logout, it redirects the user, first log out the user from its session and redirects to the main index. So finally we are having the last one, that is the login. Login also has the same captcha, and it has the same secret provided by Google API, and we have same request method of get or post, and here also we get the same email and the password. And remember, it's true is for if we want to you want the user to have this particular remember this particular email. Now if you want, if the user enters the email, so you'll have to first match the first and foremost email which is in your database. So that query has to be given, and then depending upon the captcha response, if not user, please sign up before. If not, check password hash, like password does not match, then again go to the login page. If user verification status is not one, please verify your email address. This is what all we have seen. And if not human or captcha response, so please solve captcha first. And if any of these matches, then the user will not be able to log in, or else the user will be able to log in and the username will be printed in the profile page and all. So that is what is happening here. So on the login page we can see this io@io.io, that is what we have created, and then again if I do ready first, and that's the email ID which I have already. Particular information is again io is 0, so I'll do again this set verification status for io as 1, and thereafter I think we'll be able to log in. So it will be 1, you see it is 1, and now I think we'll be able to log in. You see we are able to log in. Now there is the last thing which is remaining is we'll get the hash value, and I think I've already shown that. We'll once again get the hash value and then match onto the internet. So what is happening is once a document is signed, just like I've shown you earlier, once a document is signed, a hash value will be generated here. So let us look something about it on the network once again. So this is my user which has this particular information stored, this particular barcode signed and attached to the PDF file. So we'll first, as a normal user, will verify the authenticity of this document, and this can be done like this, and we'll submit it, and then we'll get this transaction hash value, and this transaction hash value and this transaction hash value will be matched, will be searched, can be searched on internet to find this particular information. And as you see, this is very much same. I'm just repeating for you to get the feel and to refresh what we have learned. So we'll get this particular hash value which is also present here, D2, D3, and this is D2, D3, with these are the corresponding hashes. So as it is already discontinued and set to read only, so I'll deploy a new one on Goerli or Sepolia or another testnet of another chain like Polygon or BSC, maybe in the next lecture. So if you want more, there are a lot of things to learn here, like what is a contract. Let us see this contract first. So this was the contract, and this contract has nothing here, and it was created by this particular user, and the transaction of creation was like this, created by this particular user, created this many years ago, months, this many days back, and it was created on this particular block, stored, and it was from the genesis, like from ground zero you are able to create so many number of coins. And then there are a lot more, like the transaction fees is so much, it's huge for a layman term, and then the same thing, nothing great here. So finally I've shown you the total working principle of what we are going to do and how to do it. You'll get all the soft copy of the code, and you can just rewrite it or take it from here onward as you wish, and your learning interest. Thank you for this particular lecture.